Elies Fuster, and I'm going to present this project that is called Predicting Glioma Tumor Progression and the Relationship with Proliferation, Invasion, and Angiogenesis. It's a joint project between the Polytechnic University of Valencia and the Oslo University Hospital. The main aim of this project is to try to understand the patterns in the growth of the tumor, and with the aim to predict the progression and to anticipate the key therapeutic decisions. As you know, the glioblastoma is highly heterogeneous, not just interpatient, but also intrapatient. And then it leads to different growing patterns. For example, you have nodular pattern and infiltrative pattern. That's very different. One that push the surrounding structures and then one grow infiltrating. So what are the sub-objectives we have? The first one is to understand where is the tumor growing. So we want to segment all the follow-up of the data we have, of the longitudinal data. The second we want to know is how it's growing. It's growing like a ball. It's like more like a nodular phenotype, or it's more infiltrative one. The third is to understand when. Are we able to predict when the tumor will grow and how it will grow? And then we want to know why it's growing by this way and the other. And then we want to visualize the proliferation, invasion, and angiogenesis phenomena that are underlying the growth. And finally, we don't want to just create models and make some articles and put the models in GitHub. We wanted to make this available in the clinical practice. So, okay, the materials, for doing so, we take profit of the beyond state-of-the-art protocol that is implemented in the Oslo University Hospital that includes not just structural imaging and diffusion imaging and perfusion, but also more advanced techniques such as vessel caliber MRI, vessel architectural imaging, and elastography. The first sub-objective, I want just to point out some very preliminary results we have. So the first is we wanted to just segment post-surgical data. So the first we did is, okay, we have a lot of pre-surgical data in these challenges in our own data, but there are not many models for doing this in post-surgical data. So we are trying different strategies using a small amount of post-surgical data and mixing with the pre-surgical data to obtain these models. Okay, I put some, this work is a teamwork, so I will just put the images of the people that was more involved on each part. The second is to understand how the tumor is growing. So we wanted to quantify how the surrounding tissue is displacing, and also if there is some quantification, we can quantify the compression in the peritumoral area. So we developed a method that is really part of the application to just try to quantify how the peritumoral region is compressed by the growth of the tumor. And then this is more or less how it looked like for a longitudinal study, in which we have the displacement maps and the compression maps through time. This leads us to different preliminary resolutions with overall survival. And okay, we can say that we found that peritumoral compression could be a relevant stratification marker. Okay. The other sub-objective is to see if we are able, or we can try to predict how the tumor will grow. To do so, we started working with new deep learning approaches, such as this conditional denoise diffusion probabilistic model, that it's able not just to predict how much the tumor will grow, not even where the tumor will grow based on mass, but also create or generate high-quality synthetic multimodal image. So generates how the image will look like some days before. So I think it's very interesting for us. Then after that, we wanted to analyze this model to try to differentiate which kind of information leads the model to a prediction. So then if we do some kind of explainable AI, the idea is to understand which information creates which response, and then try to differentiate the influence of proliferation, invasion, and angiogenesis on this growth. And finally, we are trying to integrate all these models that we are developing in the hospital system by including all these models in a Nordic medieval framework that we are currently working on it, and that it's already connected to the hospital packs. So it will be a great improvement. So just remember, this is a collaboration, a great team together with Polytechnic University of Valencia and the MRI Research Technology Group led by Kir Emblem. And there are just 4 projects that are supporting this big project that is funded by the cost, like this action, the Health Trust, the Research Council of Norway, and also the Ministry of Science and Innovation of Spain. So, obrigado per la vostra atenção.